Hello, in this clarity demonstration video, we will be talking about pattern match. Pattern match allows you to train a pattern and find the pattern in images. I've loaded these images that I've previously captured on a live device of a JADAK business card. We will train a pattern on the visionary word at the bottom of the card. The first step is to go up to our pattern match plugin, and the first thing after clicking on it, it will bring up a dialog asking you to train a new pattern. There are two different types of pattern matches: pixel match and edge match. Pixel match will train an image and try to match pixel per pixel on the image you are searching. We will start with that one. To train a pattern, drag the ROI over to the visionary word, and I will just adjust the ROI to the area that I want to train to. You can make this as large or as small as you want to actually train your pattern. I could train it just to the ROI, or I could train it to the whole word visionary. I could also train it to non-words. I could train it to corners or other fiducial marks within the image. I'll start by training it to visionary and accepting that as our trained pattern. Down here you'll see that our pattern that we trained shows up and that it correctly finds it within the image we are searching, within this ROI, which is our region of interest. As we cycle through the images and run the next image, I've mocked up this image to remove the Y from the visionary word. This pattern is searching inside of this ROI pixel per pixel for a match. Removing the Y results in roughly about a 10% score drop. And that's because most of the words of visionary are here. But this is an example of how the score can lower based on how the pattern is getting degraded. I could raise my passing score, requiring it to have a high score in order to pass. And you can see that this failed by the red border on the pattern match and the red ROI. I'll go ahead and set this back down to a value of 90. So as we run through the next images, this image fails because the word visionary is outside of our searching region. I can account for this by enlarging the searching region, and now it correctly finds it. And we'll continue to go through the images to make sure all the patterns can be found. Which it does. Next, I'll show you the min and max angle feature of pattern match, which allows restrictions placed on the amount of angle movement we actually want to find the pattern. We can lower the tolerances of the min angle and the max angle. Now it is no longer found because the max angle is outside of 8 degrees. This is the trained pattern which we trained at a horizontal orientation being rotated by more than 8 degrees. We can enlarge this again to find the pattern. Or you can open these angles up to allow more rotation allowed from your pattern. Next, let's look at the edge match. You could retrain a new pattern by clicking the new pattern button and selecting the edge match. Or you could go back and retrain a new pixel pattern. I'm actually going to go back to our horizontal orientation to train the images. Training generally should be done on the image that you're expecting the normal pattern to be. Here I'll select Edge Match, and now we can work on trying to train the word visionary. As with pixel pattern match, you don't have to train on just words, but it could be features. I could train on a corner and look for this corner of the card. I could look at edges of this QR code finder. But edge match will ultimately look for borders of objects with good contrast. If I train on the word visionary, the granularity and kernel size allow me to finely tune the edge match pattern. If I lower the kernel size, you'll notice the words visionary becomes more pronounced with the borders. And I can accept this as our train pattern, which finds it in the image that we were training on. And like pixel match, with the image with the Y removed, the score lowers. The difference between edge and pixel is there are less pixels being compared. It's really just the edge pixels that are being compared with edge match. So the resulting score drop is lower. Our pixel pattern match dropped to 90, where edge match dropped to 80. The edge match will be more sensitive to pattern degradation. But as I continue through the images, you'll see that the word visionary is found in the orientations. One of the benefits of pattern match is to be able to use it as an anchor for another step. We've already trained the visionary word at the bottom of the card. Next, we want to decode the barcode on the card. If we have an ROI located here, as the card moves, the barcode will go outside of the ROI. Normally, ROIs are anchored to 0, 0, the top left of the image. We can now anchor it to pattern match. This means that the ROI is now relative to the visionary word that we have trained. So as the visionary word moves, so will the barcode ROI. This step, the Y was removed, resulting in a low score and a failure, so the decode won't run because the pattern wasn't found. Now as the visionary moves, the ROI will move with the visionary word. It will also rotate to the correct orientation. This is a powerful feature. This means that you can find a fiducial in an image and have all of the following ROIs be based on that fiducial mark. This allows you to account for mechanical tolerances or movements of the object that you're looking for in the image. Pattern match is an important tool in clarity and can be used as anchor points or to finding features. One last thing to note is that when training, try to make your ROI as tight as possible to the marks in the image that you're trying to train. Also note that because pixel match is comparing a pixel per pixel comparison to the image, it generally is a more intensive operation and may take longer. Edge match is faster because it's just looking for the edges of contrast within the image. Thank you.